When you and I look at the number 42, the word hello, and a grocery list, we instantly know they're different things. But a computer? To a computer, it's all just ones and zeros. So, how in the world does it know that you can do math with 42, but you can't do math with hello? Well, that's the magic behind something called data types, and that's exactly what we're going to break down. So, think of this as us building your very first programming toolkit. I mean, it makes sense, right? Whether you're building a simple birdhouse or a massive skyscraper, you need the right tools for the job. In programming, your main material is data, and your tools, well, those are your data types, and they are what let you build anything you can imagine. So here's our game plan. First, we're going to talk about why this stuff even matters. Then we'll get into the core ingredients, the absolute essentials. After that, we'll look at how to keep things in order, how to find stuff in a flash using pairs, and how to make sure everything is one of a kind. And then we'll lay out our entire toolkit. Ready? Let's jump in.
All right, kicking things off with section 1, the language of data. Now, this might sound super basic, but trust me, getting this part right is the fundamental difference between code that works beautifully and code that just falls apart. Let's see why.
The easiest way to think of a data type is as a label. It's basically you telling the computer, hey, heads up, this thing here is a number, or over here, this is some text. That context is absolutely everything. I mean, is the 5 you see on the screen a number we can add and subtract, or is it just another character like the letter A or B? Without that label, the computer has no idea. The data type gives it the rulebook. Let's move on to our second section and start filling our toolkit. We'll start with Python's core ingredients. These are the absolute nuts and bolts, the hammer, the screwdriver, the tools you are going to be reaching for in pretty much every single program you ever write.
Okay, first up, numbers. You've got integers, which are just nice, clean, whole numbers, and you've got floats, which are numbers with a decimal point. Perfect for things like money or precise measurements. Next up, strings. That's just a bit of programmer speak for text, anything you wrap in quotes. And finally, booleans. Now, these might seem almost too simple, but they are the engine of all decision-making in your code. A boolean can only ever be one of two things, true or false. That's it. But that's what lets your program ask questions like, is the user logged in, true or false? So let's see this in the wild. When we create a variable and give it a value, Python is smart enough to just apply the right label. So age becomes an integer. Price, because it has that decimal, becomes a float. Name is obviously a string, and is active becomes a boolean. See that? Each variable now knows the rules of what it can and can't do. So we've handled single pieces of data, which is great. But what happens when you have a whole bunch of them, a collection of things? Well, that brings us to section 3, ordered collections. These are the tools you'll use for storing and organizing multiple items in a very specific order.
Now for ordered stuff, we have two main tools, lists and tuples. They look really similar, but they have one absolutely game-changing difference. Lists are mutable, which is a fancy way of saying they're changeable. Think of a shopping list on a whiteboard. You can add things, erase things, change it up. Tuples, on the other hand, are immutable. They are unchangeable. Think of coordinates carved into stone. You can't change them. So the rule of thumb is simple. If your collection needs to change and grow, use a list. If it needs to stay constant and protected, a tuple's your best bet. Let's actually see that changeability, that mutability in action. Okay, so we start with a simple grocery list, apple and milk. Then we use a special command, .append, to add bread to it, and boom, look at that. The original list itself has actually changed. It's grown. This is something you simply cannot do with a tuple, and it's what makes lists so incredibly flexible. So lists are awesome for keeping things in order. But what if you need to find one specific item in a list that has, say, 1,000,000 things in it? You'd have to search one by one by one. Yikes. Our next tool completely solves this. Welcome to section 4, the power of pairs, where we're going to unlock the lightning-fast lookup power of dictionaries. To get your head around a Python dictionary, just picture a real physical dictionary on your shelf, right? If you want to find the definition of the word serendipity, you don't start at page 1 with aardvark and read the whole thing. Of course not. That would be insane. You use the word itself to jump straight to the right page. In that analogy, the word you look up is the key, and the definition you find is its value. And that is exactly what a Python dictionary is. It's a collection that doesn't just store a sequence of items, it stores data in these connected key-value pairs. Its absolute superpower is being optimized for one thing, getting you the value back instantly, as long as you know the key.
It's all about speed and efficiency. Check out this super simple contact card example. The key name is linked to the value Alex. The key phone is linked to the phone number. So if I need Alex's phone number, I don't have to scan through a list. I just ask the dictionary, hey, what's the value for the phone key? And I get the answer back immediately. That is the power of this structure. All right, we've got one last major tool to add to our collection. This brings us to Section 5, keeping it unique. This is a very specialized tool for a very specific job, when the only thing you care about is that every single item in your collection is one of a kind. For that job, we have sets. So a set has one simple, incredibly powerful rule. Everything inside must be unique. If you try to add something that's already in there, nothing happens. It just ignores it. The collection enforces its own uniqueness automatically. And just like dictionaries, sets are unordered. There's no first or last item. You just think of it as a bag of unique things. This example right here shows the magic of sets perfectly. We try to make a set with a whole bunch of duplicate numbers, a couple of 2s, 3 3s, but look at what we get back. The set acts like a filter. It automatically throws out all the duplicates, leaving you with a perfectly clean collection of just the unique numbers, 1, 2, and 3. It's amazing for cleaning up messy data. And that brings us to our final section, your programming toolkit. We've looked at all the individual tools. Now let's lay them all out on the workbench, side by side, and admire our complete collection. Okay, this table is your ultimate cheat sheet. Need to handle text? Grab a string. Doing any kind of math? You need an integer or a float. Got a list of things that needs to change? That's a job for a list. Got a list that should never change? Use a tuple to protect it. Need to connect pieces of data and look them up fast? That's a dictionary. And finally, if all you need to do is find the unique items from a big collection, a set will do that for you automatically. You know, in the end, it really all comes down to this simple idea. Knowing about these data types isn't about memorizing a bunch of boring rules. It's about knowing which tool to grab from your toolkit for the task at hand. Trying to use the wrong tool just makes your life harder and your code weaker. But picking the right tool from the start, that makes your code faster, safer, and so much easier for you and others to understand. So there you have it. You now have the foundational toolkit of a Python programmer. You've got tools for numbers, for text, for ordered lists, for connected data, and for unique collections. The door is officially wide open. The possibilities are endless. So the only question left to ask is, now that you have the tools, what are you going to build?